Hey guys, it's Tiffany from supereasymath.com. Today, I'm going to show you how to solve systems of equations. Solving systems of equations. When solving systems of equations, there are three methods that you can use to get your answer. The first method is the graphing method, and you're going to do that on the coordinate plane. The next method is the substitution method, and you're going to isolate a variable, then plug the answer to that in to solve. And last, you're going to use the elimination method. That's when you use the distributive property to get rid of variables. Let's take a look at an example. Example number 1. Let's say I have the two equations x plus y equals 5 and 2x plus 3y equals 1. Well, I'm going to start off by graphing to get my answer. Then I'm going to use the substitution method to get my answer. Then I'm going to use the elimination method to get my answer. When graphing, I'm going to start by writing each equation and I'm going to put a table underneath it. Okay? So I have x plus y equals 5. Now I'm going to write my table x comma y. I'm going to ask myself, when x equals 0, what does y equal? And I'm also going to ask myself, when y equals 0, what does x equal? Well, I'm going to plug in the value for 0 and get my answer. Put a 0 in for x, and I can do this in my head because it's a pretty easy problem. And that leaves me with y equals 5. Next, I'm going to plug in 0 for y, x equals 5. So now I've created 2 points that I can graph, okay? I can graph the point 0, 5, and I can graph the point 5, 0. When I graph the first 0, 5, I'm going to end up with a point right here. When I graph the point 5, 0, I'm going to end up with a point right here. Then I'm going to draw my line. And it goes right through those points. Now I'm going to take the same steps, but I'm going to do it for my second equation. I have the equation 2x plus 3y equals 1. I'm going to write my table. When x equals 0, what does y equal? 0 makes this portion cancel out because 2 times 0 would just be 0 and that goes away. 3y equals 1 means y would equal 1/3. When I plug my 0 in, I'm going to get that x equals 1/2. Now I'm going to graph these 2 points. I have the point 0, 1/3 and the point 1/2, 0. Well, you might be thinking, how do you graph 1/3? Well, think about it like this. If this were not 1/3 and it were just 1, your point would be moving 0 on the x-axis and it would go up 1 point. Well, we can't go up a full point. We have to go up 1/3 of a point. So your point's going to be like right here. It's kind of not the halfway mark, but slightly below the halfway mark. So I'm going to put a dot there. Now I'm going to graph the 1/2, 0. Now those two dots end up being very close to each other, but that's okay. You can still connect them with a line, and our overall point is to see where do our two lines intersect. So let's graph our line right now, and this is what we get. Now I can see that our two lines intersect down here. Okay, this is at the point 14, -9. I went 14 spaces across my x-axis and down to the -9 mark, okay? So that's 14, -9. Now, I'm going to show you that I can get this exact same answer, 14, -9, by using the substitution method and by using the elimination method. Now, it's time for our substitution method. Substitution means you're going to solve for a variable and then plug the value in for that variable into the other problem to get an answer. Then you're going to get that answer and plug in again to get your other variable's answer. Well, Whenever I'm deciding which variable I'm going to solve for, I look at my two equations and I like to find a variable that's already kind of by itself. Like if it doesn't have a coefficient, that's a plus. So my first equation has both of its variables without coefficients. So this is going to be the easiest one to solve for. So what I'm going to do is I'm going to start by rewriting it. X plus y equals 5. Now I'm going to subtract y from both sides. X equals 5 minus y. Now I'm going to take the value that I got for x and plug it into the second equation. So I'm going to start by rewriting that equation. 2x plus 3y equals 1. Now I'm going to rewrite it, except where I see an x, I'm not going to write x. I'm going to write what I calculated x to equal. So I have 2, and I'm plugging 5 minus y because that's what we just found out x equals. And then plus 3y equals 1. Now I'm going to keep solving. I'm going to solve for y. Distribute here, 2 times 5, and then 2 times negative y. So this is 10 minus 2y plus 3y equals 1. Now I have 10, and I can simplify my negative 2y and my plus 3y, and I would get just a positive y equals 1. And then subtract 10 for both sides, and that's going to give me y equals negative 9. Well, so far it looks like we're on the right track because y equaled negative 9 when we were graphing it. Now I'm going to take the y equals negative 9 portion and plug it into the other original equation. So I have x plus y equals 5. So now instead of writing y, I'm going to write negative 9 because that's what I just calculated y to equal. So it's minus 9 equals 5. So now I'm going to add 9 to both sides. And I end up with x equals 14. Now I can see that I'm definitely on the right track because I got 14 for x. That's the same thing I got over here. That looks like we're doing good. Then I would just write 14 comma negative 9 as my answer. Now let's solve this problem again using the elimination method. I want to write my problems so that they're stacked on top of each other. And it's important that my x and y variables are written in the same position on each problem. So for both of these problems, I have my x value plus or minus my y value, and then that equals some numbers. So we're in good shape because I got that same format. I have 2x plus 3y equals 1. And then I have x plus y equals 5. So they're both in the same format. Now, when we're eliminating, what we need to think of is getting rid of one of the variables. And when we eliminate, we basically stack the numbers on top and we're going to add them going straight down. So in order to eliminate variables, they must be like opposites, okay? So if I have a 2x here, to eliminate this x with it, I would need a negative 2x here. Or I could make this one a 2x and make this one a negative 2x. Or it could be an infinite amount of variations, but the thing is they must have the same numerical value but opposite signs. One needs to be positive and one needs to be negative. And however you want to do that is fine. So what most people do is they take the coefficients. So remember, if there's just a regular x here, that means there's a coefficient of 1. And you can just multiply the coefficients by the opposite equation, but one of them needs to be negative. So I'll say I'm going to make my bottom equation my negative equation. So that means I'm going to multiply my top row by 2 because that's the coefficient for my bottom x. And I'm going to multiply my bottom row by 1, but it really needs to be a negative 1, okay? Now I'm going to distribute this. That means I'm going to take this number and multiply it by each term in this equation. I'm going to take the 2 and multiply it by x, take the 2 and multiply it by y, and take the 2 and multiply it by 5, okay? So I'm going to make this 2x plus 2y equals 10. Now I'm going to do the same thing at the bottom. My -1 multiplied by this gives me -2x. -3y equals -1. Now I'm going to add these numbers together. Well, 2x minus 2x cancels out. We are eliminating a variable. This is going to make our math easier because we have like less stuff to calculate. That's why this is called the elimination method. Now I'm just left with my 2y equals 10 and my -3y equals -1. So what I'm going to do is I'm going to stack them on top and add straight down. 2y minus 3y equals -y. And then I'm going to add straight down here. 10 minus 1 equals 9. Now, I don't want my variable to be negative, so I can remember that this is like a -1 in front of this y and divide both sides by -1. And that leaves me with y equals -9. Next, I'm going to do the same thing, but in reverse, meaning I'm going to switch and cancel out my y variables, and then that's going to give me the answer to my x. Okay, so just to make this clear, I'm going to do my second part of my elimination in a different color so that you understand that I'm not calculating for y anymore. Okay, so I need to think, what can I multiply this entire equation by and this entire equation by to make sure my y values are opposites? Well, the general rule of thumb is to take the coefficient and multiply it by the opposite equation. So the coefficient of this y with nothing in front of it is a +1, okay? And the coefficient of this y at the bottom is 3. So I'm going to put a 3 here, and I'm going to put a 1 here. But remember, one of them needs to be negative because we need to end up with one being negative and one being positive, so they cancel. Now, if your sign had one of them as negative, you wouldn't have to worry about that because it already is going to act as a negative because of that sign. Like if it were subtraction here, that you would not need to have one of these as a negative, but I'm going to make my 1 negative, okay? So now I'm going to rewrite this whole problem, except I'm going to write it with the 3 distributed with it. So 3 is going to get multiplied by my x, 3 is going to get multiplied by my y, and 3 is going to get multiplied by my 5. So I have 3x plus 3y equals 15. And then for my bottom row, I have -2x minus 3y equals -1. Now, because I have a +3y here and a -3y here, these cancel out. This is going to make my math easier. Now, I have the equation 3x equals 15. Then I have the equation -2x equals -1. Well, these get added together, and you end up with a +1x, and that equals 14. And as you can see, this is consistent with all of my answers I've gotten so far. X equals 14 and your y equals -9. So if I were to write that as an ordered pair, it would be 14, comma, -9. So that's the same thing I got for my substitution method, and that's the same thing I got when I graphed. So as you can see, when you're solving a system of equations, you have 3 ways that you can do it, and you should get the same answer every time. If you're not getting the same answer, then something's wrong somewhere. Okay, so the answer to example number 1, which basically means where do these 2 lines intersect on a coordinate plane, is 14, comma, -9. Let's take a look at example number 2. Example number 2. 3 apples and 2 oranges cost $16. From the same shop, 4 apples and an orange cost $13. Find the selling price of apples and oranges. Well, first, I'm going to write this scenario, this word problem, as an equation. I'm going to write, well, if I have 3 apples and I add 2 oranges, I'm going to get 16. Then I'm going to write it again, but for the second part. If I have 4 apples plus an orange, that's $13, okay? These are my 2 equations that I created from this, okay? 3 apples, okay, that came from here, and that means plus 2 oranges, cost, that means equals $16. We just made a sentence into an equation. 3 apples plus 2 oranges equals $16. From the same shop, 4 apples, okay, and an orange, that means 1 orange, costs or equals $13. So 4 apples plus an orange equals $13. Now, first thing I'm going to do is get rid of this O, because you know you can look at this and totally throw yourself off and think that's a 20 and a 0. It's not. It's an O. Because I know I'm going to graph these, I'm actually going to write them as X and Y values, not as A and O. So I'm going to say my A's are my X value and my O's are my Y values, okay? So I'm going to rewrite this entire equation, but instead of an A and an O, I'm going to write an X and a Y. So I have 3X plus 2Y equals 16. And I have 4X plus Y equals 13. Isn't that amazing? We just took a real life scenario and turned it into an equation. Actually, 2 equations. Okay, I'm going to solve this using the graphing method, just like I did on example number 1. Equation is 3x plus 2y equals 16. Well, I have x and a y value. I have a 0 here and a 0 here. If I plug in 0 as my x, that cancels out this portion. And then I'm left with 2y equals 16, and I can see that y would be 8. Now I'm going to do the same at the bottom. Plug in 0 for y, and this portion would cancel out. And then I'm left with 3x equals 16. Well, I would divide both sides by 3, and that would make x equal to 5.3 repeating, or 5 1/3. Now I'm going to do the same thing, but with my second equation. I have 4x plus y equals 13. I got my x and my y. I got a 0 here and a 0 here. Plug in 0 for x and I get y equals 13. When I plug in 0 for y, I get y equals 3 1/4. Okay? Now I'm going to graph these points. I have the point 0, 8. When I graph that, that's going to be here. Then I have the point 5 1/3, 0. 5 1/3 wouldn't just be at the 5 mark. It would be up a little more, not at the halfway mark, but a little less than the halfway mark. So around there. And then I'm going to connect these two with a line. Okay. Now I'm going to graph 0, 13, because that's a point I just calculated. 0, and your 13 would be, if this is 10, that's 1, 2, 3. 13 is here. And then I need to plot the point 3 1/4, 0. 3 1/4 would be here, 0. So the point 3 1/4 would be right here. When I graph those two lines, I get something that looks like this. Now, remember, when we're finding a solution to a system of equations, the purpose is to figure out where those two equations intercept each other. So when you graph them, you can visually look at it. And that looks like it's at the point 2, 5 to me. So I'm going to write 2, 5. So if I were to graph to solve this, I would get 2, 5. Now, if you remember, for the substitution method, you want to solve for a variable and then plug that value into the other equation and then plug the answer you get for that back in to get your final variable answer. Well, when I start off substitution, I always think, well, which variable is going to be the easiest to solve for? And in this case, it's going to be that plus y, because there's no coefficient in front of it. Like all of these other ones, you would have to subtract the other variable to the other side, and then you would end up having to divide by a number. Well, with this y, I'm not going to have to divide by anything because there's no variable in front of it. So I'm going to solve for the y first because it's like the easiest thing I can get. It's already kind of by itself. So I got 4x plus y equals 13. And then I subtract 4x from both sides. So I have y equals 13 minus 4x. Now, because I calculated what y equals, I'm going to now work with the other equation, the first one. And instead of writing y, I'm going to write what y equals. Y equals 13 minus 4x. So that is 3x plus 2. Don't write a y, write a 13 minus 4x. And that equals 16. So now I'm going to solve by using the distributive property. 3y plus 26 minus 8x equals 16. All right. So now I'm going to continue to solve this, and I'm solving for x at this point, meaning get the x on one side of the equal sign by itself. That's my goal right now. So let's see. What terms can I combine? What things can I move around? I'm going to combine my 3x and my 8x and get a negative 5x plus 26 equals 16. Now I can move my 26 to the opposite side, and that gives me negative 5x equals negative 10. Now I'm going to divide by negative 5, divide by negative 5, and I get x equals positive 2. Well, now I need to take what I got for x and plug it back in to one of the original problems. Well, which one do you plug it into? Well, I'm going to plug it into the very first one I wrote down, the one over here. So 4, don't write x, write what x equals now. Well, we just figured out that it equals 2, so I'm going to write 2 plus y equals 13. So now 4 times 2 is 8 plus y equals 13. Minus 8 minus 8, y equals 5. And that's correct, because over here, when we graphed, we got that y equaled 5. So the answer is 2, 5. So if I were to graph to solve this, I would get 2, 5. And also if I use the substitution method, I would get 2, 5. Now, I'm going to solve using the elimination method. So I'm going to write my problems and make sure the variables are in the correct positions and they're stacked on top of each other. And the way I originally wrote it at the top of my problem actually looks correct, so I'm going to leave it just like that. 3x plus 2y equals 16, and 4x plus y equals 13. Now I'm going to think, well, what can I multiply both of these equations by? And it's going to be something different on the top than the bottom to make sure my x's cancel out. I'm going to do x's first. And so I'm like, well, switching the coefficients is usually the easiest way. So I'm going to multiply the top by a 4 and the bottom by a 3. Well, one of them needs to be positive and one of them needs to be negative. It doesn't matter which one, as long as you end up with opposite signs, because they need to cancel out. So now I'm going to use the distributive property to multiply across each way. Okay, so 4 times 3x is 12x, plus 4 times 2y is 8y, and 4 times 16 is 64. Now I'm going to distribute, but with my negative 3 on the bottom. So I end up with negative 12x minus 3y equals minus 39. Now, I'm going to cancel these out. See, we are eliminating. We got rid of a variable. This is going to make our math easier. Kind of like, okay, get rid of that. Now, I'm going to just add, going straight down. 8y minus 3y equals 5y. Equals 64 minus 39, 25. Now, divide by 5 on each side. And this is leaving me with y equals 5 over here. Okay, and again, we're on the right track. We've got y equaling 5 for the other problems as well. Okay, so we're doing good. Now I'm going to take that y value, and I could plug it back in to calculate the x value using the substitution method, or I could just use the elimination method again to figure it out. What can I multiply both equations by to get a new equation that cancels? And that would be -1 and 2. And that's not the only answer. There's other combinations you could do that could give you that. And remember, I'm getting that because I'm using the coefficients There's nothing in front of this y, so that means it's a 1. There's a 2 in front of this y, so that means it's a 2. So I'm going to switch the positions. So there's a 2 at the bottom and a 1 at the top, but one of them has to be negative. It doesn't matter which one. And I just made the top one negative this time. And when I rewrite this, meaning -1 times all of this, I end up with negative 3x minus 2y equals negative 16. Then when I distribute my 2 across the bottom, I end up with 8x plus 2y equals 26. Now I'm canceling as much as I can. My negative 2y and my 2y cancel out. Now I'm left with negative 3x and 8x, and that is 5x equals 10. Negative 16 plus 26 is going to give you 10. Divided by 5, divided by 5, x equals 2. So we did that one correct because my x value is 2 and my y value is 5. So I consistently got 2, 5 for every time that I solved that problem. So that means I'm doing everything correctly. Let's take a recap. When you're solving a system of equations, you can solve by graphing, and you're going to do that on the coordinate plane. You graph the lines of each equation, and you figure out the point where they intersect. You can also solve by the substitution method. That means you're going to isolate a variable and then plug the answer for that in to solve. You can also use the elimination method. This means use the distributive property to get rid of variables. Now you try. Comment with your answer below. The sum of two numbers is 54. Their difference is 6. What are the two numbers? Remember, just like in our last word problem, you're going to take that scenario, turn it into an equation, then turn the second part of the scenario into a second equation. Then you're going to use one of the methods I just taught you to calculate your answer.
You can check out more of my work at supereasymath.com.
Did you find this video helpful? Well, you can get more help from me on my website, supereasymath.com. While you're there, you can pick up my top 5 math tips to make learning math easy.